from our graph, right? Visual 2 gave us this equation. The rate of change equals 0.683 centimeter per number of knots, millimeters, or thickness. And it basically goes to 0 when it's on there. Now, from that, what we can do is we can put the thickness of our steel cable in, right? And if we put the thickness of the steel cable in, we'll get out a rate of change of how much it will change for each knot that we put in it. Okay? So what was our thickness of the steel cable? What? 50 centimeters. I just want to check one thing real quick. It's cool. Did we write down this part here? Okay. So we're getting the equation of the line now. All right. So let's put that in. See. So this is on our analysis page, and we got minus 0.6832 centimeters per number of knots over millimeters. Do I put in 50 centimeters for my thickness? Well, I do, but I'm not going to put it in as 50 centimeters. I'm going to put it in as what? It's got to be millimeters. So 500 millimeters. That just goes to 0. The number's going to be 300 something, so that 0.5 doesn't really affect it much. So minus 0.6832 times 500 is minus 340, about 342. The millimeters cancel. Centimeters per number of knots is our rate of change. So we took all our data and put it together so that we could see that it's going to change, how much the steel cable is going to change each time we put a knot in it. Yes. Where did the what? Oh, our problem is a 50 centimeter thick cable. So now we took all our data together so that we can get the rate of change per knot for our thick cable. And so we're extrapolating out our data to this thick cable. Okay? So here we got this. Now if you remember, we had up here this formula for somebody's rope where it was length, rate of change, number of knots, plus the original length of it. So we're going to do that for this so that we have that situation for our steel cable. The length equals our slope, which is minus 342 centimeters per number of knots, times the number of knots, plus L0, which is the y-intercept, but is our original length of our cable. So that's just like the problem that you had for your individual notes. Elizabeth. Yes. Yes. Yeah. That's the original length. So this formula goes right back to the one that we worked on up here. For this rope, this is the L0. So somebody started this, and the original length was 138 centimeters. Down here, now we're going to do it for the steel cable. You see? Okay, let's go back to here and write this step in our analysis and our plan. What? Well, it was supposed to all be written together. That's why I told you to leave space for your plan. But so you can just put that in right around the formula that we're writing now. Okay? So it could be in like right here. Okay? So your plan is going to be mixed up throughout. Some of you did left space, some of you didn't, but that's all right. So calculate the rope length. You get 4 knots, 50 centimeters, with a cable length of 60 meters. So do you have that written down? Everybody's got that already? Or no? All right, well, go ahead. Alrighty. So remember, this is all online, right, for the write-up, so if you need it for this time around. Back to this. What? Read the objective thing again here, okay? Come back to the original sheet. It says, the length of the cables after the knots have been tied must be 60 meters. What is that in this equation? L. So this has to be 60 meters, but since this is centimeters, I have to put it in centimeters. So 6,000 centimeters equals minus 342 centimeters per number of knots times number of knots, which is going to be what? 4, right? It has 4 knots plus L0. Now this L0 is what we want to find, so we're getting really close to getting our problem. So 4 times minus 342 is minus 1368. Excuse me, because those cancel with a calculator right here in my head. I should have made you think that I could do that quickly. Although 8, 16, it wouldn't really be that hard. 6,000 plus 1368 is 7,368 centimeters equals L0. So our original length of our steel for our bridge should be 7,368 centimeters, or original cable length. Oh, crap. Oh, I'm sorry. I meant crust. Okay, about 74 meters. Of course, we made this estimate with the thickest rope being this. And we extrapolated up to this. And this is made out of cloth or nylon, and that's made out of steel. Now, the ropes are probably pretty similar in structure, but there could be a lot more give in this rope than the steel one, right? So there's obviously estimates. Now, if we look at a perfect knot, like this one here, and we cut through it, so this is the next part of your plan. Oops. Oh, I didn't want to click that. No big deal. Is the next part of your plan, if I can find it, is this: theoretically calculate the rope length and get percent difference. It should really say percent error. Put percent error, because the difference is like you do something and I do something. Let's see the difference. Percent error is a comparison with like taking one that you calculated or came up with and comparing it with a theoretical value or a known value sometimes. In this case, it's sort of like a known value, but there's limits to the theoretical calculation too, but because of the shape of the knot. Percent error, ERROR. Okay, so if we took the rope knot and we went through the center of it, it would sort of look like this, where the distance from here to here and here to here and here to here is the circumference of each of the rope. Okay? So it goes around the rope there. And we know a circumference is equal to, so we're trying to figure out how much length in each knot that's tied, how much length is lost. So looking at the knot, like in this transect, this cross section of it, we can see that it's like 3 circumferences next to each other. And a circumference is pi times the diameter, but the diameter is the thickness of the rope in this case. And there's 3 of them. So the lost length for each knot is equal to 3 pi times t. But what is t for our steel? 50 centimeters. So 3 times pi, don't be surprised there's a big difference between this and 342. 3 times 3.14 times 50 is 471 centimeters. So theoretically, we should lose 471 centimeters for each. Okay? Pi times t. That's a t. Kind of crazy looking. There you go. Does that look better? Not really. Okay? So it was really this. So if we look at that, so for 60, we have a 60 meter length rope that we want with the 4 knots. So 60 plus 4 times 470, or, oh no, wait. 60 plus 4 knots times 4.71 meters would give us a rope length. The L0 theoretically, because each knot is going to take this much length out, right? So 4 of those in there is going to mean that we're going to need a 78.84 meter length rope. Yes. .471 centimeters. So what does that mean? That means we just took the knot and looked at its geometric shape. From its geometric shape, we could figure out how much rope is lost each time we tie one of these things. So that's what I did here. And I see that for each knot, it's 471 centimeters of rope that will be lost. Okay? And so with 4 knots, that's going to lose, it's about 4.71 meters. 4 times 4.71 added to 60 gives me this. Now I can do the percent error. And you have the percent error formula on your sheet, your that sheet of equations I gave you, some equations, some information, constants and stuff. You could go to the next page and then just start your. You almost got it all. So you can just start your critique below that, or go to the next page. Could be your critique. Yes, that's 471 centimeters. Again, 471 centimeters. Okay. So the percent error. This is the check portion of your lab. Is the measured value minus the expected value, or in this case, the theoretical value, over the theoretical value. It's good to be thinking like it's always like the 1 minus the better over the better times 100. So what did we get when we measured it? We got 73.68 meters. So that this is 73.68. Theoretical was 78.84 divided by 78.84 times 100 equals 6 point. Yeah, well, one I just did a quick calculation to see what geometrically its shape would be. How much how much rope would be lost from the geometric shape of the knot. The other one, we did all that data and all our work to find the answer, right? So we're seeing how different we were from the theoretical value, okay? And how much we were 6.5% difference. And this is usually in parentheses or in absolute value, okay? Now the rest of the lab you have to do yourself, right? But not really, because what? Well, I give you the sheets of it, right? I already gave you the part that's written out. So you really just have to take things and put them into your own words this time. But as you're doing that, I want you to be thinking about what's written and how it expresses. So it's a good thing to do that as you're following along with the rubric of what each thing needs and the description of it on this. You see when it talks about each section, look at this as you're doing that. Okay? So you have to write up each piece of this in there, and as you're doing that, you should be following along with it. So when you go to here, you'll see we go back, like on the critique page. What the heck? Oh, no, that was the second page, sorry. So there's a section, Achieve Purpose. Read what the achieved purpose is in the front of your lab notebook. Then look at this, and you can rewrite it a little bit. You don't have to just copy it word for word. And then look at limitations, simplifications, troubleshooting, okay? And, okay, so you do each section of it. Okay, but I'm giving you this so that you're learning how to do it, not just so you just copy it. You see the key? Because the next time you got to do it yourself, so you got to know how to do it. Okay? Now, if you... What? Well, you... No. I mean, you could. I don't mind if you get together and work on it. That's fine. But now the rest of it you're going to do on your own, at home. Or you can, if you want to come into class and work on it, that's fine. But you have all the data. We solved the problem. You just have to write it up. Well, that took a little longer than I was expecting, but that's okay. Because you got to set it up for it to be, so you can learn from it as we go. All right, so now if we go to, is anybody still confused about what they have to do there? What? Yes, we just finished answering the question. 2 different ways, and then yes, that's the homework. For when? Wednesday. Tuesday is the, oh wait, is it opposite? Well, I have it written down. The Knots lab is due on Wednesday. The chapter block is due on... We just did it, but you have to write it up. You have to finish it. What? This part? This? You might come up with better simplifications and limitations and stuff. No. Right now we're going to look at... Where did it go? This is on the critique. Look at your sections. On the rubric, it has on there, it has a critique page, right? On the critique page is troubleshooting. Troubleshooting is defined in the beginning of your thing under the critique page on this thing. See? So if you go to critique, you can see troubleshooting. Describe mistakes made in the data collection or analysis and your steps taken to minimize these mistakes. That comes after limitations and simplifications, because I don't want you describing your calculator mistakes as actual limitations of the lab, you see? So each of the sections is described here. Online, under labs, there's a fuller document that gives more descriptions of each section. Okay? So you can do that. Now, we did some problems from 1.1. We did this one, and then that was it, okay? So let's look at some others. All right, so this is a part that we can do from knowing about lines and units, y versus x and stuff, okay? So Oops. Gosh. There's so many things I gotta click on. If we look at this problem, it says in this expression G equals 20K minus 8, G is measured in goats, so that's the units, and K is measured in kittens. Okay? Find the units of these constants. So in the problem, what does the 20 represent? It's a slope. Now slope we know is like change in y over change in x, right? So what would be the units on 20? If our y is g, so that's goats, right? And k is kittens, what would be the units on our slope 20? Goats over kittens, right? Does that make sense? Who can tell me what the units of 8 are? Oh, first off, tell me what 8 is. It's a y-intercept, right? What are the units of y? Kittens, right? So what would be the units of 8? Kittens. So if I told you something like, what? It is goats, I'm sorry. Whoopsies. Good catch, though. No, it's just goats. It's negative 8, but the units is goats. So if I said, like, how many goats do you have if I give you 30 kittens? Let's say 3 kittens. How many goats? It would be like, but it's 20 goats over kittens times the kittens, which was, how many did I say? 3 kittens minus 8 goats. So these cancel, so I have 60 goats, whoops, minus 8 goats. I put lines and not follow it. 52 goats, right? That would be our G for 3 kittens, right? Yes. Someone say Mr. Ring? No? I'm hearing things? Uh-oh, that's not good. Just kidding. Okay. Now we talked about fundamental quantities, right? Mass, what were the units for that? Kilograms. Length, meters. Time, okay. What would be the standard units of this thing? With a mass. What's the units of mass? It's easy. Kilograms, what's the units of length? What's the units of time? So that's easy, right? Times second squared. The percent difference one. Okay, this is a good one to look at because if you look on your sheet that says your reference table, oh, here we go. Nope, that's the wrong one. Maybe I could just, God. Can I see it? Oh, that's your packet. This one, okay? You see how it says on there percent error and percent different? It says first number minus second number over first number on there if they have equal validity. So in this case, I mean, if you take the first number to be 34.5 and you're comparing it with 35.1, so there's some ambiguity about which one you choose to subtract and divide by. But the answers are always close. They should be close to each other. So in this case, percent difference would equal the first number minus the second number over the second number times, or is it over the first number? See, I don't really like that, but whatever. Times 100. So, well, in this we're doing a percent error and comparing it to a theoretical. Okay? 34.5 minus 35.1, oh crap, is not right. 34.5, and you take the absolute value, okay? So zero point 0.6 divided by 34.5 times 100 is 1.7%. Okay? Saved by the bell. Have a nice weekend.